Hello everyone. Today we'll start with the second lecture for the module pre-stressed concrete, and today we are going to see what are losses in pre-stress. So let us see what do you mean by losses in pre-stress. So basically whenever we stress the tendons and we use that in pre-stressed concrete member, so there are various losses which occurs in the stress in steel. So we have to find out these losses because it is very important to know the actual stress diagram, because which we are considering it for design. So the losses are quite sometimes significant. So hence these losses should be taken into consideration before we design the section. So that is the importance of losses. So let us see what are losses. So the steel wires of a pre-stressed concrete member do not retain all the preliminary pre-stress. So as I've mentioned just now, that the steel wires, whenever we provide the pre-stress to the steel wires, they do not uh, retain all the stresses. A certain amount of loss of pre-stress always takes place. So a loss of pre-stress will thus affect the stress distribution of the member. So as I mentioned you that certain amount of losses will always take place. There are various reasons for that. We'll discuss in detail. So a loss of pre-stress will affect the stress distribution of the member. Therefore, it is necessary to estimate the probable loss of pre-stress. So I hope it is clear so far that it is very important to find out the losses in pre-stress, because that is going to affect your stress distribution of the member, and based on the stress distribution we are going to design the member. So it is very important to first know what are the various types of losses. So in general these losses may be classified into the following. So let us see the various losses in pre-stress. So these losses can be classified under three headings for the convenience. So let us try to understand. The first is the loss of pre-stress during the tensioning process. So this is we are going in the ascending order. So whenever we tensioned the tendons, so there is bound to be some loss, and that loss is nothing but a loss due to friction. So always remember that there is certain amount of loss due to friction in the jack and the anchorages, and it is different for different systems of pre-stressing. So the second is loss of pre-stress at the anchoring stage. So once we have tensioned the tendons, after that what we will do, we will anchorage. We will anchor the tendons. So at that point of time also there will be some losses, and that loss is nothing but loss due to slip at the anchorage. So at the anchorage system also you will have some losses. So generally what happens, so there always exists a certain amount of friction in the jacking and the anchoring system, right? So because of this, the readings which is shown on the pressure gauge is not the actual stress which is there in the tendons. So that is the reason there exist certain losses due to the slip at the anchorage. And the third one is losses occurring subsequently. So these are the losses which will occur after the first two steps, that is after the tensioning and after the anchoring stage. So in this we can see that there is loss of stress due to shrinkage of concrete, and then there is loss of stress due to creep of concrete, and then loss of stress due to elastic shortening of concrete, and the last one is loss of stress due to creep of steel. So now we will see all these losses in detail. So just let us first classify these. So we have understood that these are the various types of losses. So basically there are 6 losses, and we have just for our convenience we have classified into loss at the tensioning stage, loss at the anchoring stage, and losses occurring subsequently. So here I've also mentioned the classification of losses based on the time. So it is also divided into immediate losses and time dependent losses. So in immediate losses we have elastic shortening of concrete, loss due to friction, and loss due to anchorage slip. And in time dependent losses we have loss due to creep, loss due to shrinkage, and loss due to relaxation. So I hope you understood by this figure that what are immediate losses and what are time dependent losses. So time dependent losses are the losses which occur over a period of time, and immediate losses are the losses which occur immediately just after you tension the tendons. Okay, so now we can see all the losses together. So what I've done is I've just tried to explain all the losses together so that it is easy for you to refer this whenever you solve the problem. So remember this classification is very important so that it is easy for you to understand the numericals. So the first loss is loss of prestress during the tensioning process. So we will just go as per the order which we have seen the losses. So we'll start with the tensioning process, that is loss due to friction. So loss due to friction, we have the formula as Fi into K into L, where Fi is nothing but the initial stress and K is your friction coefficient for wave effect and L is the span of the member. So basically we have three formulas for this. So it depends on the data which is provided in the question, and accordingly we will use the formula. Okay, so the second is initial stress into mu into alpha plus k into x, and also we have one more equation, that is px is equal to p naught into 1 minus mu into alpha plus k into x. So I'll just explain what are the terms involved in this equation. So Fi is nothing but your initial stress and k is the friction of coefficient for wave effect. So remember now, whenever we are talking about loss due to friction, so we have two coefficients here. So it is, this loss is divided into two types: loss due to the length effect and loss due to the curvature effect. So this k is the frictional coefficient for the length effect. The length effect is also called as the wave effect, and this mu is the coefficient for the curvature effect. So I hope you understood now why there are two coefficients for loss due to friction. So one is for the length effect and one is for the curvature effect. And alpha is the cumulative angle in radians when we draw a tangent to the curve. So that is your angle alpha, and k is normally taken as 0.0015 per meter. So I've also mentioned this. So I've readily for you mentioned some values which are generally taken in the numericals. Suppose if you are not provided with those values, so you can definitely assume this value and proceed with your problem. So don't worry, generally the value of k will be given in the question most of the times. So what is Px? Px is the pre-stressing force at a distance x from the tensioning end. And what is P naught? P naught is your pre-stressing force at the jacking end, or you can also say it as a initial pre-stressing force. And L I have mentioned before as a span of the member. So that was the first loss, that is loss due to friction. And the second is loss of stress at the anchoring stage. So whenever you anchor the tendons, so again as I mentioned you, there is bound to be some loss due to this stage. So loss due to slip at the anchorage is given by delta E into es upon L. So what is delta E? Where delta E is the effective slip which will be given in the question, which will be generally in mm, and es is nothing but modulus of elasticity of your steel tendon, and L is the length of the tendon. So I hope this is very clear. Loss due to slip at the anchorage is nothing but delta E into es upon L, and modulus of elasticity of steel will also be given in the question. So the next loss is losses occurring subsequently. So now I have just numbered the losses. Can you see the first loss due to friction? I have numbered it as 1. Second, so we have seen in the previous slide that there are total 6 losses. I hope you have noticed that. So we are discussing those 6 losses together so that it becomes easy for you to refer this and learn these equations, and hence we can solve the problems based on this. So loss occurring subsequently, we have loss due to shrinkage of concrete. So now loss due to shrinkage of concrete is given by shrinkage strain into modulus of elasticity of steel. So first of all, let us try to understand what do you mean by shrinkage of concrete. So shrinkage is nothing but it is the contraction of concrete due to chemical changes and drying. So basically it's a contraction, it's a deformation. So shrinkage shrinkage happens due to the conditions. It depends on the moisture conditions, and it is independent of the stresses in the members due to loads. So how can we reduce the shrinkage? By minimizing the water cement ratio, we can definitely reduce the shrinkage in concrete. So I hope you understood what is shrinkage of concrete, and the equation for this is given by shrinkage strain into S, and it is the notation is epsilon cs. So shrinkage in concrete into es. And I've also mentioned the normally the values taken for this shrinkage strain, it is between 200 into 10 raised to minus 6 to 400 into 10 raised to minus 6. So since it is a strain, so it is a dimensionless quantity. So now the next loss is loss due to creep of concrete. So the loss due to creep of concrete is given by phi into m into c, and you have one more equation for this, that is epsilon cc into fc into s, where epsilon cc is nothing but creep strain in concrete. So let us see what are the terms involved in this equation, loss due to creep of concrete. So phi into m into fc, phi is nothing but your creep coefficient, and it is generally taken between the range 1.5 to 2. So normally it will be given in the question, and m is the modular ratio, which we have already seen in TRCS. Modular ratio is nothing but the ratio of modulus of elasticity of steel to modulus of elasticity of concrete, and these values will be generally given to you in the question. And fc, what is fc? Fc is the average stress in concrete at the level of steel. Okay, so fc is your average stress in concrete at the level of steel, and it is given by the equation, P by A plus PE square upon I. So this we will see while we solve the numerical. Okay. And what is ECC? As I've mentioned, it is the creep strain in concrete. Okay. So now let us understand what do you mean by creep of concrete. So creep of concrete is nothing but the deformation in concrete, which depends upon the interval of time to which the member is loaded. So creep again is nothing but your deformation, and which depends on the time. So over a period of time, the deformation which happens in concrete is nothing but your creep of concrete. So I hope it is clear now. So now going to the next loss, it is loss due to elastic deformation, or it is also called as loss due to elastic shortening of concrete. So what happens whenever you stretch the tendons and then again it is released? So the tendons try to regain its original length, and while doing so, they compress the concrete or they shorten the concrete. We have discussed it in the first lecture. So this shortening of concrete is nothing but your loss due to elastic deformation, and it is given by m into fc, where m is your modular ratio and fc is your stress in concrete at the level of steel, which is given by p by a plus pe square upon I. And then coming to the last loss, which is nothing but loss due to relaxation, which is given by percentage of the initial stress. So generally the range is 1% to 5%, and normally we can take this loss due to relaxation as 3%. So this value will be generally given to you in the question. So any values which is not given in the question, we can assume the general value like 3%. So loss due to relaxation is nothing but your percentage of the initial stress. So what is loss due to relaxation? This is nothing but your creep in steel. So like we have creep in concrete, similarly the creep in steel is termed as loss due to relaxation. So I hope all the 6 losses are clear to you. So I have directly given you all the equations and with all the terms involved in it, so that it is very convenient for you to Just refer these equations and solve the problems. And I must tell you that this losses in concrete is a very important topic, and questions can be asked from this topic, and it is a very scoring topic. So now let us just see the last thing which is involved in this topic, that is, so whenever you're dealing with frictional loss, there are two cases. So the cable is pulled from one end, and when the cable is pulled from both the ends. Okay, so when cable is pulled from one end, you can see the jack, and the theta is nothing but the angle made with the tangent, that is slope. So whenever, in the first case, when the cable is pulled from one end, your alpha cumulative angle is given by 2 times the slope, and your x distance will be the total span length or the total span of the beam, where slope is given by 4e upon L, where E is the eccentricity of the cable from the neutral axis. So for a parabolic cable, it is slope is given by 4e by L, and for linear cable slope is given by 2e by L. Okay, and the next case is when the cable is pulled from both the ends. So when the cable is pulled from both the ends, your cumulative angle alpha is equal to the slope, and your distance x which you have to consider while solving the problem is nothing but your span of the member by 2, that is L by 2, and where theta I have mentioned, for linear cable it is taken as 2e by L. So you just have to remember these two cases. So whenever it is asked in the question, it will be mentioned that the cable is pulled